Welcome to Brain Ponderings, your window into neuroscience, neurology, psychology, psychiatry, and their interface with society, and their importance for medicine, but also other aspects of human uh, endeavors. My guest today is an expert, world expert on memory, and particularly he's focused on something that's not focused on so much, although because of him, it's got a lot of attention. That is the fallibilities of memory, which he'll talk about. So Professor Daniel Schacter, he's endowed professor of psychology at Harvard University. He's a member of the National Academy of Sciences, so obviously well recognized as a leading expert in his field. He's author of a number of books. The one that he's got the most, I think, interest in, and he's spent the most time thinking about, is the Seven Sins of Memory. And so, Dan, welcome.
Thank you, Mark. Happy to be here.
Can you talk a little bit about your early life? Did you have parents who were either, in the scholars or some field of science?
Not really. My father was an insurance broker, and my mother was a reading teacher, so a little bit there. But I got interested in psychology in high school. I think it was my junior year. We had a health course, and it was the teacher had a segment on psychology that sort of grabbed my attention, and that's when I first started thinking about psychology as maybe a major in college.
And where was that? Where did you grow up?
I grew up in Westchester County, just outside of New York City, New Rochelle, and then Scarsdale, and I graduated from Scarsdale High School.
Ah, the Scarsdale diet.
Yes, yeah.
I've over the years done a lot of work on intermittent fasting with a focus on the brain since I'm a neuroscientist, so I'm a little bit familiar with that. Um, okay, and then you went to University of North Carolina
I
for
did.
your bachelor's work?
To Chapel Hill. Part of the reason for going there was that I was pretty good at golf in high school and
Ah,
won the club championship at the club we belonged to, and I had the fantasy maybe I could go to a southern school and play golf, but I quickly found out I wasn't nearly good enough to make a college golf team. But it ended up being a good experience for me, and they had a strong psychology department, and I was able to major there in psychology, pursue those interests.
and do you still golf?
I do.
Yeah,
I do
good,
still play.
good.
Still hanging in there. Occasionally hit a good shot.
And then, okay, so then when you really start getting into the hands-on research, was in your PhD work, obviously, and that was up in Toronto.
Yeah, there was a big transition for me occurred between my senior year at Chapel Hill. I was really focused on clinical psychology, but then through a series of events, I was hired into a research assistant position with Dr. Herb Krovitz. He was over at Duke University and the Durham Veterans Administration Hospital, cognitive psychologist who had been working primarily on perception, got interested in memory. I was his research assistant, so I did some of his experimental testing, and that included an increasing focus on patients with memory disorders at the nearby VA hospital. He kind of split his time between Duke and the nearby VA. And seeing some of these folks who would present as most seemingly normal, have a normal conversation with them, but then perform extremely poorly on standardized tests of memory, even though they might have a normal language, normal IQ, and other things. And in extreme cases, I could spend an hour with one of these patients, walk out of the room for 5 minutes, come back, and they would have no idea who I was or what we had been doing, even though they seem to be completely, functional when you're dealing with them. So that's what got me interested in memory. And so I went up to Toronto, University of Toronto, which at that time was really a world center for psychological research on memory.
Yeah, the both Toronto and Montreal, Wilder Penfield was he was in Montreal,
Yes.
but
Well, it was Brenda Milner in Montreal. Yeah.
yeah, yeah.
Yeah, and Penfield, I think too. Yeah.
Right. So your experience at Duke then with these patients that had memory problems but appeared normal when you talked to them, you wouldn't know it. So this was in the 70s, is that right?
That was from 74. I graduated UNC 74. I worked with Quoverts for 2 years and then went up to Toronto in 76, got my PhD in 81.
So that's well before there was much brain imaging going on.
Correct. And I got interested in the brain basis of memory because of these patients. And that was the main inroad that we had, if you're interested in human psychology, into what is the brain basis of memory at the time. Because a lot of these patients, they didn't have gross, extensive brain damage affecting the entire brain. They had fairly restricted damage in many cases, including the famous case, of course, of HM that uh, was reported in the 50s and in which the neuropsychologist Brenda Milner played a key role. Um, he, of course, had surgery that in which to prevent the spread of epilepsy, they took out his medial temporal lobe, including the hippocampus. Nobody knew at that time that that would have devastating effects on his ability to establish new memories, and they found out that it did. And so that was really our main way of looking at brain substrates of memories back then in the 70s and 80s until the advent of neuroimaging in the late 80s and early 90s.
With HM, so we did a lot of work with like canic acid seizure model or these cytotoxic models where you can selectively damage hippocampal neurons
Hmm.
and and so in the rodents, and I would assume it's similar in humans, you really have to have these are bilateral structures, right? There's a
Right.
left hippocampus and a right hippocampus. Now, did HM have damage to both sides?
Yes, that was
Yeah,
bilateral,
yeah.
and it impacted almost all the hippocampus and a couple of other parts of the medial temporal lobe. So it wasn't just the hippocampus; it was
Yeah.
nearby structures within the medial temporal lobe, but it was definitely bilateral.
And maybe that's why in part these are so rare. Uh, you see these people because there's some redundancy, not only, left and right, one can compensate, but probably circuitry, and you have to have a certain particular damage to specific.
Yeah, the main way that we see these patients where it's not what you're looking for as a memory researcher are, patients who have relatively specific damage. Again, as alluded to earlier, you're not, if someone has memory problems and language problems and attentional problems and so on and so forth, you're not going to learn a lot about memory. So you're looking for those cases where it's pretty selective. And so to the extent that there's a lot of damage within the medial temporal lobe, not too much damage outside that, although in some cases you do have restricted damage, for example, to the frontal lobes. That adds a certain kind of deficit to the memory problem. But it's those selective cases that were and still are of interest, even though, of course, we have like 30 years of neuroimaging now under our belts. The study of these patients is still relevant and important.
Yeah. Okay, so let's get into the seven sins of memory. We know, everybody's getting older, myself and you included.
Yes.
And although I think I've done this kind of thing throughout my life, but there's certain things like you get distracted from something. You go in a room, you're going to do something, then, there's somebody there, you start talking about something, you forget. But and that's kind of normal. So these seven sins of memory are normal. These are kinds of, I wouldn't say necessarily, I guess they're kind of deficits, but on the other hand, they may have some positive value too. because we have to kind of prioritize things that are important. So I guess just start going through these, starting with what you call the sins of omission.
Yeah. And I would agree with everything you said there, that there's both positive and negative to these, and that these are normal parts of memory that don't, indicate that somebody has like a neurological problem or anything like that, when they're expressed, within the normal range that we see. But so what I call the sins of commission, it's basically breaking down forgetting. We're all familiar with forgetting into three different kinds. I call them transience, absent-mindedness, and blocking. So transience refers to loss of information or forgetting over time. We're all familiar with it, all of the things being equal. It's harder for me to remember what happened 6 months ago than yesterday, all of the things being equal. So that was initially shown in psychology, the curve of forgetting, by the psychologist Hermann Ebbinghaus way back in the 19th century. And it's just a totally normal part of memory, loss of information over time. I contrast that then with absent-mindedness, which refers to a breakdown at the interface of attention and memory, such that we're distracted, as you alluded to earlier. We're maybe multitasking. We can get back to that later on. And information really never gets into memory in a way that's going to allow it to be retrievable later on. So that would be a breakdown at the interface of attention and memory at the time of encoding. You can also have a similar breakdown at the time of retrieval, where you've encoded information, the information's available, but for example, you become distracted, you get into a conversation with someone when you intended to go into the kitchen and get something out of the refrigerator. You get into a conversation with your spouse, and now you've totally forgotten what you want to do. So that would be, again, a breakdown of attention at the retrieval side. And that can have some very interesting and severe implications in some everyday cases. And then the third sin of omission I call blocking. So this refers to cases in which information has not faded over time, still available in memory. You're paying attention, you're trying to remember, and you may even have cues available to try to remind you of what it is that you're trying to recall, but you block on the information. You can't get it at the time that you need it. And the most common experience for most people would be tip of the tongue. You're trying to recall someone's name. You might recall all kinds of things about them. You know their occupation, you know where they live, and you just cannot come up with that name at the time you want to retrieve it. So that I would call blocking. And the proof that the information is there is that, the next day or an hour later, it may pop to mind. So it was there all the time. For whatever reason, you just couldn't get at it. So those are the
And
three sins of commission.
my experience with that last one, the blocking, is that um, in the moment, the more I try to remember it, the harder it gets. And then if I quit trying to remember it, then whatever, a few minutes later or something, it seems to pop into my head.
Exactly, because what happens in those moments is we're trying to generate cues to help us remember, and they end up being creating more interference, doing more harm than good. They get us more off track. We
Yeah.
become absorbed in, maybe generating a name that sounds like the one. If we're trying to recall a person's name, we generate a name that sounds like the one of the person we're trying to recall. That can sometimes interfere with getting to the exact one that we want to get to. And then just walking away, forgetting about it for a second, may allow you to retrieve the information later on.
So with these fallibilities of memory, they're normal, but I assume you have some way to kind of test these and quantify them or semi-quantify them. Is there like a standard bell curve if you just take a bunch of people and do some tests, if you can test these different uh, domains of memory or fallibility? Is there like a standard curve?
Well, The way I would look at it would be that there are a variety of neuropsychological tests that have been validated on people without brain damage, where we can put a particular score in the context of what is normal, or are you above a cutoff, for example, for impairment. So that the standardized tests tend to come from neuropsychology, where you've got population norms. Experimental psychologists are less concerned with, trying to establish what's normal or not, and trying to look at, in any particular situation, what can I learn about a particular aspect of memory by manipulating experimental variables, if I'm a cognitive psychologist, or putting people in the scanner and looking at what brain areas become more active or less active, or show other interesting kinds of effects when I scan people and they try to remember. So I would say the closest thing we have to like a bell curve from intelligence tests comes from neuropsychological tests, where we have population norms against which we can compare someone to see if they're declining on a particular aspect of memory, and for diagnosis of things like mild cognitive impairment in older adults, or Alzheimer's disease reflected by memory impairment. Those become really important.
Yeah, ideally, you'd want to optimize your cognition, right? For, I guess, whatever your occupation is and so on. And so I guess let's just wait on that till we get through the other four sins of memory. So uh, the commission sins.
Right. So I've got four sins of commission, um, three of which have to do with memory distortion, that is, remembering something, but what you're remembering is incorrect in some way. And the fourth has to do with intrusive memories. So the first one of the sins of commission I call misattribution. So this would be, for example, recalling a new fact correctly and then claiming, oh, a friend told me.
Yeah.
That's how I know this new bit of information, when in fact you saw it on TV, or vice versa. You misattribute the source of your memory. And that can be really important when people confuse the source of their memory. It can have a lot of important implications.
Yeah.
Related to that is one I call suggestibility. So this is when misinformation is presented to us as a suggestion, perhaps, hey, did this incident happen to you? And I describe something that might have happened to you, and you think back, and you take that suggestion in and you say, oh yeah, I think I do remember that happening, when in fact it didn't. And there's a lot of important work on suggestibility and leading questions, particularly in legal contexts. We know that misleading suggestions or misinformation, when presented to eyewitnesses, can have really um, practically important negative effects on the accuracy of memory. So suggestibility is something that has really been extensively studied, particularly in relation to legal settings. Um, the third sin of commission that has to do with memory distortion I call bias. And this is one of the more subtle but pervasive memory sins. So bias refers to the fact that when we remember a past experience or retrieve knowledge of the past, um, we're often influenced, sometimes influenced to recall incorrectly, by our current knowledge, beliefs, and feelings. So it's been shown that often what we remember about the past has more to do with what we currently know, believe, and feel than what actually happened in the
Yeah.
past. And so this is a more subtle kind of memory distortion, retrospective bias, some people call it, but I think it's pretty pervasive. And then finally, the fourth of the sins of commission I call persistence, which refers to intrusive memories, often of disturbing or even traumatic events, information that you wish you could get out of your mind, but you just can't.
Yeah.
It may sort of take over your life, and you have recurring intrusive memories that in extreme cases can be associated with or a symptom of PTSD, post-traumatic stress disorder. These intrusive memories are one of the cardinal symptoms of PTSD, in fact.
Yeah, and in that case, so in general, we tend to remember things that have some emotional context,
Right.
either negative or positive, probably.
Yep.
And so, and there's actually some ideas on what's happening, right? With you activate certain pathways and like norepinephrine
Yep.
play a role in that, and some circuits. So are these sins of commission? A lot of this, you test these through language, right? So humans have spoken and written language. Some other animals may have more primitive, undoubtedly do, forms of communication. Um, are these sins of commission usually, what's the relationship with language? In other words, if, yeah, I'll leave it at that.
Yeah. I obviously they're usually expressed through language in humans, but we do have like animal analogs, of maybe not all of them, but at least several of them. You refer to, for example, emotional memory, and we know that emotional memories are the basis of these intrusive or persistent memories, because emotional memories, positive or negative, tend to be the best
Yeah,
remembered.
yeah,
And there are 2 points to take away from that. One, there are a lot of good animal models on fear memory, for example, where language is not involved, but you see a lot of similar effects in non-human animals in terms of the underlying neural substrates. We know through decades of work that brain region called the amygdala nearby the hippocampus plays an important role in various kinds of emotional memories, both in humans and in non-human animals. So that would just be an example of I think, the basic operation of memory. Yeah, it's expressed in language in people, but um, I don't think language is determinative, of the nature of that function. The second point about emotional memories that's really important goes back to something you mentioned earlier, which is that even though these memory sins can be damaging, so in the case of persistence, again, they can be psychologically even disabling, there's another side to it, the positive side, which is that you want a memory system that will prioritize highly arousing or threatening events that could possibly threaten your survival. You want a memory system that's going to allow you to really remember those, even though the sort of the dark side of that is that those same processes that might allow you to avoid a threatening event in the future by making them highly vivid, highly accessible, can result in these intrusive memories that I refer to as persistence.
let's, as you go through these, and let's start talking about the digital age and
Mm-hmm.
the media, social media,
Yep.
regular media, and several of these sins are would seem to be very important in what's going on nowadays with, for example, the emotional context. Seems to me, although I don't know what data there are on this or not, that people would say they're someone with very popular podcast, unlike mine, and uh, you know they show a lot of emotion when they're saying things like they're mad at such and such a party for this or that, and my intuition says a lot of people are more maybe attracted to that, but also more likely to remember something if the person espousing that information, is very emotional when they
Yeah, I think that follows from everything that we just
Yeah.
discussed. I don't know of any specific studies on that exact topic, podcast hosts who are emotional versus less so, but I think we could be pretty confident in the results that there's going to be an impact of emotion on the memorability of what is said. There are other factors that are going to contribute to that as well, but probably I would suspect that there would be an effect of emotional arousal to the extent that that is translated to the listener who feels that same emotion, and then you get that boosting effect of emotion on memory.
One thing the algorithms do, as you know, is they keep amplifying something you've already looked at in interesting ways. We go on YouTube and start looking at whatever videos of such and such a topic, and then another ones will keep coming up. The other thing is, so your environment, your media environment kind of becomes pigeonholed in certain ways. And then we also tend to live in, the people we interact with often, uh, amplify certain uh, angles on a particular topic and so on. So these have seemed very important in what we remember and what we emphasize when we recall things.
Yeah, absolutely. I mean, you've touched on an important point because I think those kinds of processes that you describe with respect to memory are amplifying the effects of something that we know is one of the most reliable memory boosters and something that typically can work in our favor. And this is known as retrieval practice. Some people call it the testing effect. And this is what's been shown over and over again, that retrieving information from memory is one of the surest ways to boost the uh, your subsequent memory for that information. Even in studies where you contrast one group of people, for example, reading stories over and over again. Another group of people read the same story, but then get tested on their memory for the story. If you look over time, uh, initially there may not be much of a difference between the two groups, but if you go out to a day or a week, the group that has read the story and then been tested on it will have much higher long-term recall than the group that's read the story over and over again. So it's the act of retrieving information is really a potent modifier of memory. So to the extent that the algorithms and other processes, that you're just referring to, get you to retrieve information of a certain type over and over again, that is going to amplify the cycle with respect to memory, where that's really going to be at the forefront of your memory through that boosting effect of retrieval practice.
And that's how it. So we have a granddaughter that's a little over a year old now, and it's amazing at that age, right? She can't yet speak except for a few words, but it's very clear. She has a lot of information in her brain that she remembers, right? All different animals and so on. And as and certain things get amplified just through the daily interactions.
Right.
And so there's an evolutionary, very important reason for that, I think, in terms of uh, parents passing down to their offspring critical information uh, that's necessary for them to get by uh,
Yes.
in that in that setting. Now, one thing I often wonder about is so we did work on intermittent fasting, physical exercise, effects on the brain, and we evolved in like hunter-gatherer situation where we're out, whatever, in the woods or the plains every day, foraging or hunting. And it seems in that kind of situation, a lot of your critical thinking and remembering what you are remembering what you see as you move through the environment. I think that actually thinking about things while you're physically moving amplifies your memory. It kind of makes sense to me that it would be that way. Um,
Yeah, I
is there,
think, action is one way of elaborating on a memory.
yeah.
So, that goes back to just the importance of memory encoding, and that can be done in a variety of ways, verbally, um, elaborating on information, or through action, can elaborate on um, incoming information in a way that makes it more memorable over time.
Now, for a lot of my creative thinking historically has been, I used to do a lot of running, trail running, and then now mainly I do bike or walk. And like when I'm writing, I don't know if you do this, but I think a lot of people do. When they're writing something, they'll, whatever, write a number of paragraphs and then take a break, go for a walk. And then you kind of, in your mind, as you're walking, you think about what you wrote and kind of formulate what you're going to write next. And I don't know if it's true, but my impression is if you don't take that break and walk, you're less creative or you're aren't as productive.
Yeah, I think there's something to that. People have talked about that as a kind of incubation effect
Yeah.
in creativity. We're changing the context in a variety of ways, including the way you described, uh, can help you with creativity. One thing we've been interested in over the last 5 to 10 years in my lab is the role of our memories, specifically our episodic memories, memories of personal experiences, in uh, affecting and amplifying creativity of a certain kind. So, what we have found through some experimental procedures in the lab is that if we get you into a mode of like recalling a lot of specific details about a recent experience that you had, and then we ask the question, how does that spill over into a creativity task? Okay, so we've just shown you a video, people doing stuff in a kitchen. And in the relevant condition now, I'm asking you to go back and remember that video in as much detail as you can, the sights, the sounds, what happened. And then I say, okay, thank you. And now I'm going to give you what's called a divergent creative thinking task. Standard task for that is called the alternate uses task, where I give you a common object such as a brick, and you have a certain amount of time to come up with unusual and appropriate uses for a brick. And we're going to score you on that. How many unusual but workable uses for a brick do you come up with? What we found is after you've just done that video where you've delved into your episodic memory for a recent event in detail, compared to various control conditions, you now come up with a couple of more novel uses for a brick, because we think that mode of detailed episodic retrieval can help you kind of simulate scenarios in which you might use a brick in an unusual way. So we've been working on that recently, and we have some neuroimaging evidence that suggests that when you've had this procedure of recalling information in detail, and I scan you when you're doing the alternate uses task, you see a little more activity in the hippocampus. We talked about earlier, of course, an important structure for memory. So there's some interesting relationships between memory and creativity that we and others have been finding.
In humans, the prefrontal cortex is uh, expanded a lot compared to lower primates and other animals. And there's a lot of work on that over the last number of decades.
Mm-hmm.
Um, it plays a role in decision making, in kind of impulse control. How do circuits in the prefrontal cortex impact, or how would you do this? You'd have to actually do an experiment where you manipulate. Oh, okay, this is a good time. There are ways to activate or maybe even inhibit
Mm-hmm.
certain circuits, or at least certain areas, circuits in certain areas of the brain, non-invasively, right?
Right.
Transcranial magnetic stimulation.
Yeah, TMS, we've used that. Yep.
So you're doing experiments where the idea is you try to modify the activity in a certain brain region, and then in the laboratory setting, see how that affects someone's recall or whatever
Yes.
aspect of memory. What are some of your interesting findings in that kind
Well,
of?
some of our TMS studies touch on what we just talked about, the relationship between memory and creativity. So when you do TMS, you can only apply it to the surface. You're not sticking an electrode deep into someone's brain. But even though you only apply it at the surface, there's evidence to show that TMS to certain regions that you can get at by applying surface stimulation will affect regions that are functionally connected to them. So it's not just the region
Yeah.
below where you're putting the magnet and stimulating that's impacted. It may be some downstream regions. So what we found in a paper published a few years ago was that if I give you TMS to a part of the parietal lobe called the angular gyrus, um, that is accessible to TMS and it's connected to the hippocampus, what we find is if you've just had stimulation to the angular gyrus, we now put you in the scanner and you do the alternate uses task that I just talked about, and you do a future thinking task where I give you a cue word and I ask you just to imagine a future event. In earlier work, we and others had shown that when you imagine a future event, you activate a lot of the same brain regions as when you remember an actual past event. So in this TMS study, what we were able to show is that applying TMS to the angular gyrus impacts the hippocampus. We're able to show that because we scan people, and the reduction in hippocampal activity when you're performing either the alternate uses task, come up with a novel use of a brick, or what we call an episodic simulation task. We give you, maybe brick, and we say, imagine an event that in the next few months might happen to you involving a brick. We show that you come up with fewer novel uses for a brick after you've just had the TMS that impacts the hippocampus. And you also come up with a less detailed imagination of a future event. So it kind of links together the hippocampus with some of these regions that aren't specific, some of these functions that aren't specifically memory functions, but are very much impacted by memory.
Yeah, the hippocampus is so heavily studied, and for a lot of reasons. Some reasons are practical. For example, in animal studies, the the circuit organization is very well organized, and uh, it's easy to know whether you're stimulating, you know, an input to a certain neuron, recording from certain neurons. And a lot of the work on encoding of memories has to do with incoming information, right? So your different senses, vision, hearing, touch, taste, that information goes into primary cortex and then uh, secondary cortex. But anyway, it funnels into the hippocampus through the anterolateral cortex. So in that case, the encoding of memories, the idea is like if you, in at the same time, you see something and hear that thing that you're seeing make a sound, then you're pairing those two inputs in time. That information is coming in, and then maybe where you get convergence of those inputs, you get strengthening of synapses. But I think it's what's less well understood about the hippocampus is that how it's important roles in recall, and then in, like you're saying, like envisioning future scenarios based on information that's already in your brain.
Yeah, that's something that we and others have really only been studying intensively for the past decade and a little more. And actually, the one of the initial instigators of that line of work came from some observations in the early 80s um, that were made by Endel Tulving, who was my PhD supervisor and who I work with for a number of years. Uh, After getting my PhD in Toronto, and I was running something we call the Unit for Memory Disorders. And we had this really interesting patient. He's known in the literature by the initials KC. He had had a motorcycle accident that resulted in damage to the hippocampus and also the frontal lobes and part of the parietal lobe. So it wasn't a pure case of medial temporal lobe or hippocampal damage. He had some other damage. But even though he performed well on IQ tests and so forth, he had a complete lack of episodic memory for personal events. He could not recall any single event from his past. And I worked with him for years, and I never saw any evidence that he could recall a single personal experience. He had kind of general knowledge of his past. He knew where he grew up, he knew his parents' names, knew where he went to high school, but he couldn't tell you about any one specific incident. So there was a testing session, which well, Tulving and I were testing him, sitting across the table from him, and Tulving asked him a very simple question. Try to tell me about what you think you might be doing tomorrow. Now, we knew that if you asked him, tell me something you did yesterday, he couldn't tell you any one thing that he had done yesterday. And the striking observation from this testing session was that more or less the same thing happened when you asked him to imagine what you might be doing tomorrow. He would just say, my mind is a blank. If you pushed him hard, he would say something like, well, maybe I'll have breakfast and then I'll have lunch. But he couldn't conjure up any specific episode of what he might do any more than he could remember any specific episode from his past. That was really striking and suggested a connection between remembering the past and imagining the future. Um, I didn't do anything about that for a long time, but about 20 years later, we started doing brain scanning studies where we put healthy people on the scanner, gave them cue words, asked them to remember the past or imagine the future. And then we saw this striking similarity in the brain regions that showed increased activity when people did those two tasks, including the hippocampus and a bunch of other uh, connected regions in what many people refer to nowadays as the default network. A bunch of brain areas, including frontal parts of the frontal, prefrontal cortex, parietal lobes, temporal lobes, that become active when you kind of focus attention within. Um, and they behave similarly when people remember the past and imagine the future.
Yeah, and this again, I'm thinking of the information overload environment
Mm-hmm.
of today, where
Yes.
um, maybe people's default mode networks aren't being used much because they're constantly being bombarded with things coming from outside.
It's a really important question. And this is something I got into in this article on memory and technology, because what you see now, and I think it's a legitimate concern, you'll often see internet headlines the internet is the internet killing our memory? Are our phones ruining our memory? Because we're relying on them so much, we're offloading. Maybe what we're not using our own memories in a way that is going to have very negative effects. And there's some reason to think that there could be very general effects, negative effects of using technology on our memories. So there's a famous finding from Eleanor Maguire in London about 25 years ago, known as the London taxi driver study. A lot of people may already know about this, where she studied these taxi drivers in London and found that they had larger hippocampal volume than like a control sample. And you might say, well, maybe that's just because people who have a large hippocampus, which makes them more able to remember, routes that taxi drivers had to remember, at least in those days. Maybe that makes them more likely to go into taxi driving as a profession because they already have a large hippocampus. But she was able to show that actually the growth in hippocampal volume is correlated with your experience, positively correlated, driving a taxi. So it seems that the causality there is that a lot of taxi driving increases hippocampal volume. So now you might wonder, well, wait a second, if that's true, and most of us now rely a lot on our GPS to get around, could the reverse be true? Because I'm relying on my GPS, maybe my hippocampus is going to shrink, is going to show a reduction in volume over time. Um, and there have been studies.
I definitely, so I grew up in the 60s and well, early 70s. I was in high school, and my father and me and my brother used to train and race standardbred horses, trotters and
Mhm.
pacers. Here's some of the bits from a couple of
Oh,
our
wow. Cool.
best horses. But I would be the navigator, so wherever we were going, I'd read the map, and I got so it didn't matter whether we're going north, south, east, or west. I could flip the map around in my brain and tell my dad, make a right here. I remember where I go. And now my kids, particularly my daughter, she could not, I don't know if she could get anywhere she's been before,
Right.
outside of, things she does every day without the GPS.
Yeah. Yeah. I think that's a great example. Two extremes there of different ways of
Yeah.
growing up with respect to spatial memory. And so we might ask, is it the case that now, many of us have shrinking hippocampal volume? Well, I think that we have to be a little more careful in the way we're thinking about it. So if you look at the literature, there's not a lot of research on it, so we don't really have a definitive answer. But there certainly is evidence that if you rely on GPS versus navigating on your own, you will have poorer memory for that route that you're navigating. If I ask you about it later on,
Sure.
when you use GPS, that's not surprising. So it can have a negative effect on your recall of the specific route that you're driving, for example. Does that mean now that there's a more general effect such that I'm generally going to have a problem recalling routes, or recalling spatial information, regardless of whether I'm using GPS or not? And that's where things get a little murkier. That's where the evidence is much less clear, whether there's a more general effect. That would be like the reverse of McGuire's hippocampal volume, where our hippocampus is shrinking. There is some evidence to suggest that people who self-report relying on GPS a lot have performed more poorly on spatial memory tests, that even when nobody's using GPS, than people who say, I don't rely on GPS very much. But we don't know whether that reflects a causal influence of using GPS a lot having a negative impact on your ability to remember a variety of different kinds of spatial information, or whether it's that people who have a poor spatial
Can
navigation
be.
memory to begin with tend to rely more
Yeah.
on using GPS. So there's a chicken and egg problem that needs to be sorted out. McGuire sorted it out with respect to the taxi drivers, but we don't have it really sorted out with respect to the effects of GPS. But it certainly makes, a lot of sense that extensive reliance on GPS could have this, more general negative effect on memory. We just don't have really solid evidence of it yet.
No, and the human brain's remarkable for its adaptability,
That's right.
and there's obviously been a lot of repurposing, of neural circuits since. There's some evidence from measure of skull volumes that human brains on average haven't increased in size uh, in the last 10,000 years, and maybe even are decreasing a little bit. But yet,
Hmm.
and people are becoming, I think, more specialized. You know, they they're specialized, learn some tasks, and so anyway, there's a lot of adaptability there.
Yes, there is.
Yeah. Uh, right. Okay. So what about you mentioned suggestibility and implanting memories that result from suggestion or misinformation. Is that issue amplified by the digital media?
I think it has the potential to be because uh, we hear a lot about fake news,
Yeah.
and there was a really cool study published a couple of years ago, or like a realistic real life study in Ireland of people who were about to vote in a big referendum on whether to repeal their restrict abortion laws. Yes, I want to repeal. No, let's keep it the same. And these people who participated in the study were shown like fake news headlines along with photos that made their side look bad or the other side look bad. Like, people on the yes side would be shown something where someone a leader on the no side is implicated in some sort of scandal, makes them look bad, but it's fake news.
Yeah.
And what was found is that when you show these folks these fake news headlines, that a decent percentage of them will claim, "Oh, I remember seeing that," as if it were real. It's not,
Yeah.
and that the incidence of acceptance of these suggestions of fake news uh, reflected your bias. So if you're on the yes side, you are more likely to accept fake news, false memories
Yeah.
of people on the no side, and vice versa. So I think in this atmosphere where we have a lot of misinformation floating around, there's now a pretty solid body of evidence to suggest that it can function as suggestion and result in implanted memories where people will say, "Oh yeah, well I actually remember that happening." Well, no, you don't. You just remember the fake news headline.
Yeah. Uh, uh, Dan, beyond the educational aspect of your work, and advancing knowledge of how the brain works, how memory works, and the fallibilities and so on, do you have some ideas on how to translate this information in ways that improve the lives of individuals or society or maybe policy making? I mean, you mentioned earlier on the law, and that's one area where this kind of things, I mean, it's well known that eyewitness testimony isn't very reliable, but what are you thinking about that? I know as I get older, I think more and more about, you know, what is my work? How can it impact, outside of the realm of science?
Right. It's an important question. I'm glad you mentioned the law because I think that's one of the areas where a lot of this work on memory has had the most impact. First of all, just in reminding us that memory can be fallible. It's not always fallible, but it can be, and to have, uh, to suggest the need for corroboration of eyewitnesses. So you can't just go with exactly what they say. Another area that's important with respect to the law has to do with the best way to put together a lineup so that people don't generate false identification. So there's been a lot of research on that, on whether it's better to show all the suspects at once or uh,
Mm.
or show them one at a time, and you have to make a thumbs up thumbs down decision on individuals. And right now, the literature on that is a little bit murky, but it suggests probably simultaneous lineups where you present them all at a time might be um, result in more accurate identifications, even though sequential lineups, thumbs up, thumbs down, probably reduces the number of false identifications, but may also reduce the number of hits as well. So that's certainly one area where I think a lot of this work on memory has been important. And then really going back to my roots, where I began testing patients, you want to think about, well, what implications does this work have for improving the lives of people who have had brain damage and are afflicted by memory disorders? And I think we do have now an impressive body of work over the past few decades that has shown, what kinds of strategies are going to be effective for these people, how we can take advantage of some of their preserved memory abilities to teach them everyday tasks that can improve the quality of their lives. One of the important things about these amnesic patients, memory impaired patients, and this was a big emphasis of my work years ago, is that they have some preserved aspects of memory. They can learn certain new skills even though they don't remember having learned them. They can learn new information even though they don't remember necessarily how they've acquired it. And we were back in the late 1980s able to show that with one severely amnesic patient, for example, we were able to take advantage of some of these preserved abilities to teach her the knowledge and skills
Yeah.
needed to perform a job in the real world and put her back to work. And so I think the more we've learned about some of those preserved abilities, we've been able to apply that to the improving the lives of people who have memory problems.
Yeah, and that's really valuable for caretakers and relatives and of the people, if one can inform them on kind of the best ways to have this person reach their potential based on, what they're capable of.
Yes.
Because a lot of times they're undoubtedly capable, their capabilities go beyond what is apparent to their family or other people. Yeah. Yeah.
Yeah, it's not always obvious that they even have some preserved abilities, which they
Yeah.
typically do.
Yeah. Um, right. A lot of my work had to do with brain aging and Alzheimer's disease. And my father actually had dementia, wasn't in the end diagnosed as Alzheimer's disease. He um, he was a lawyer, prosecuting attorney in Olmsted County, Minnesota. I went to Mayo High School. There's a high school named after the Mayo Clinic
That's the
there.
Mayos. Hmm.
And then my father retired when he was 60. And then I mentioned the harness horses, right? So we had like 100 acres and a training track, so he did that. But then my mom died young when she was 67. She was a smoker and overweight and a lot of issues related to that. So then my dad was living alone on the farm, uh, not having much social interactions. And then about 15 years later, he started to show signs of short-term memory loss, the typical thing when I talked to him on the phone, he asked me the same question
Hmm.
several times, forgetting that he'd already asked me. Then we took him up to see Ron Peterson at the
Hmm.
Mayo Clinic, and he
Yeah.
diagnosed him with probable AD. And we entered him, uh, he got enrolled him in their Alzheimer's research program there. And so he'd go in every year, get cognitive testing, MRI, some other things, CSF draw. And then he passed away at 90. And it's kind of the typical thing. He declined over like 8, 10 years. Um, but then the pathology on his brain, it turns out he had something that's called by some people, well, it's essentially severe loss of hippocampal neurons with not tons of amyloid
Mm-hmm.
pathology, some amyloid pathology, some tau pathology, some TDP-43. So it's kind of a mixed dementia. He had some vascular issues. But in his case, it was really interesting because one thing with typical Alzheimer's patients, they have a lot of mood, beyond the memory problems, they have a lot of mood swings. Their circadian rhythms get messed up, so they're sleeping in the day. And so my dad didn't have either of those, but he had the severe short-term memory loss. So that's probably reflected ultimately in the kind of the hippocampal focus of his pathology.
Yeah, makes
Yeah.
a lot of sense.
But I think from an environment standpoint, so my interpretation is after my mom died, my dad wasn't getting a lot of cognitive stimulation, and he wasn't a lawyer anymore. He didn't do a lot of reading. And so one way to keep your mind working well as you get older is to do what you and I are doing now, right? Keep engaged in intellectual activity. So I would encourage, anybody who plans on getting old, which is everybody, keep your mind active. That's one of the best things you can do besides exercise and not overeating. Have you, it would be interesting there's a lot of evidence that people with diabetes, obesity, insulin resistance, they're more prone to cognitive impairment as they get older. Have you any interest in or done any studies looking? It would be interesting to look at some of these, using similar protocols, I guess, to you're using in a lot of your past studies, which are mainly in younger people, Harvard students, I guess. Um, do some of those things in at-risk groups of people and see if you can tease out any interesting differences compared to, say, age-matched people with less risk based on their metabolic status or whatever else.
Yeah, there is a literature on that. I mean, I've had a program in research just on normal aging for quite a while, in which, we try to chase down some of the effects that we observe in young and see how they change in old. That work has been particularly important in impacting, for example, some of the early examples of we talked about remembering the past, imagining the future, similarities between the two. We see in older adults, the two tend to decline in a similar way. You remember the past in less detail, you imagine the future in less detail. And there's been work, not from my lab, but there has been some really interesting work more on the future thinking side than the memory side about how engaging in trying to richly imagine a future event can actually be helpful in avoiding, in helping obese individuals to avoid overeating. There's some very
Oh,
interesting work
that's
on episodic future thinking, and how if you simulate future events in a certain way, it can help you to avoid overeating where that's going to be a problem for you. So there, and it's interesting the various tentacles of basic research kind of slip into different clinical domains.
yeah. Well, everything we do has to do with memory, right? And memory recall, and that makes us who we are.
Hmm.
And so I appreciate you taking the time for this, Dan. I know you're extremely busy there. And besides, besides your work in the lab, uh, what about real world environments? Are you involved in any studies? Because it's the tests you make up in the lab are, they can give you readouts that are reliable, I guess, and so on. But in the real world, do they translate well?
Yeah, I think some of them do. I've been involved in some collaborations, for example, on anxious patients. patients with anxiety and looking at future thinking and anxiety and how some of the phenomena we observe basic lab phenomena play out in people who are really anxious. I have a collaboration that's been going for a number of years on future thinking in people with suicidal thoughts. People are prone to possible suicide. That's with a clinical psychologist who studies the suicidal thoughts. And we've been looking at how some of the paradigms we've developed to look at both episodic memory and episodic future thinking might be helpful in possibly, helping us to inform who's going to be more likely to actually make a suicidal attempt based on the way they're thinking about the future. So even though I'm not a clinical psychologist, I've had a number of collaborations over the years with people working with clinical populations and hope to continue that.
Yeah, that's great. That's a really important work that can help a lot of people. Thanks again, Dan, and have a good rest of the summer.
Yeah, thank you for having me, Mark. I enjoyed it.
Okay, bye.
Bye-bye.